Hi, I'm Kim from Captis Aire. Did you know there's about 1 gallon of terpenes in every oven-dry ton of wood product, and that these terpenes are very valuable and could be collected and sold and used for things like sustainable aviation fuels? Did you know that industry could implement an advanced air pollution control technology that could help them to meet their sustainability goals, as opposed to creating more carbon emissions? Captis Aire is developing an advanced air pollution control technology that could help industries to generate revenue, drive down operational costs, and improve the sustainability characteristics of their process as they clean the air. We have a great team. Hal and his team in Environmental CNC have been fantastic partners with us every step of the way since 2015. And we're working with one of the world's largest oriented strand board and lumber producers. On the terpene side of the business, we're working with the University of Dayton and the Navy, both of whom have world-class sustainable aviation fuel capabilities. We'd love to add ORNL as a partner in this effort. This team has the necessary capabilities, integrity, and passion to deliver. I worked for Georgia Pacific in a variety of roles, and our story starts there in 2015 with this project. In our work, we filed 2 patent applications on which I'm the primary inventor, and I'm proud to say I've licensed this technology. And with this license, we could own any intellectual property that we develop associated with the terpenes. So for instance, if we develop a sustainable aviation fuel, we could own that IP. So here's the problem in our story. When wood products are manufactured, volatile organic compounds, or VOCs, are volatilized off the wood. And these VOCs must be abated with an air pollution control device. Today, a device called the Regenerative Thermal Oxidizer, or RTO, burns these VOCs, which creates greenhouse gases. The alternative is to utilize the fluidized bed concentrator, or FBC, to very efficiently capture and recover over 90% of these VOCs, which in the case of drying green pine wood are composed primarily of terpenes. This enables our customers to recover and sell these valuable terpenes, as well as reduce energy usage. This chart demonstrates the importance of this problem by quantifying the energy and greenhouse gas reductions. These energy reductions are possible because there are massive amounts of air coming out of the dryer at the wood products manufacturing site that go into the RTO and have to be heated to over 1,400 degrees Fahrenheit to burn up the emissions using natural gas. By contrast, with the FBC, we can adsorb the emissions at the temperature that the air comes out of the process, and so almost eliminate this natural gas. These reductions in natural gas usage translate directly into reductions in greenhouse gases. And these reductions can be measured, registered, and verified using accepted carbon accounting methodologies. The result is we can reduce energy usage by over 10 trillion BTUs per year, a 75% reduction. This is at 50 sites. Here are 2 RTOs. Placed end to end, they are longer than a football field, and they burn over 200 billion BTUs of natural gas per year. And this is the natural gas we can almost eliminate with the FBC. So here's how this technology works. Processed air enters the adsorber. It passes up through a series of trays filled with activated carbon beads that very efficiently adsorb these VOCs. Then the clean air exits out the top. The beads are then conveyed pneumatically to the desorber, where they're heated to release the VOCs in vapor form. These VOCs are then moved to the condenser and converted to liquid. Here on the right, you can see what our high quality terpenes look coming straight out of the condenser in our pilot unit. We have strong evidence for the scientific feasibility of this technology. For instance, we've already successfully demonstrated this technology 3 times in pilot testing. In the third, we were online for over 1,700 hours over 6 months at a commercial-oriented strand board mill. And we have isotherm data that demonstrates that activated carbon very strongly adsorbs terpenes. Here are our risks and a risk mitigation plan. We must be able to reactivate and reuse the activated carbon media. Otherwise, it will get full, stop adsorbing, and we won't be able to clean the air. So the good news here is we use a specialized activated carbon. California Carbon has been reactivating successfully for years. In fact, they provide a reactivation warranty that they will return the carbon to 95% of its new, unused adsorption capacity. We must also be able to collect economically viable quantities of these high-quality terpenes. Again, the good news here is we already know there's 1 gallon of terpenes in every oven-dry ton of wood product. So for a wood products manufacturer making 300,000 tons per year of wood at a 75% yield, we could collect 225,000 gallons a year of terpenes, a sufficient yield. We must also be able to provide an economically viable upgrading methodology that's scalable at our toll manufacturing site. Again, the good news here is we have preliminary data from the University of Dayton and the Navy that they can catalytically upgrade the terpenes to terpenes that meet the pre-screening criteria for sustainable aviation fuels. Finally, more good news, ORNL already has expertise and capabilities in all of these areas. And if invited into this program, we could utilize these very valuable capabilities to further reduce risk. We have a significant competitive advantage, and that's because we can drive down the long-term cost of ownership and improve the sustainability characteristics of our customers' process. For example, the capital cost of the FBC is competitive with that of the RTO in the West at about $20 million. In addition, we can drive down operational costs primarily by reducing energy usage, reducing maintenance costs, and selling terpenes. These reductions in energy usage translate directly into reductions in greenhouse gases, which improves the sustainability characteristics of our customers' process. Our customers have been telling us they've been looking for an alternative to the RTO for years. In fact, one customer even told us they'd like to replace all their RTOs in the next 10 years. They even gave us a $5 million letter of intent in support of this technology. We know our markets well. We'll be selling 2 things, equipment and terpenes. On the equipment side of the business, we can sell into the $2 billion RTO market. On the terpene side of the business, we already know there's offtake agreements in place for 200 million gallons per year of sustainable aviation fuel. As compared to the less than 30 million gallons of sustainable aviation fuel actually sold in 2020, you can see there's a significant upside opportunity to fill this gap and sell terpenes. This is a very viable business opportunity. This chart projects revenue and EBITDA for selling just 20 FBC systems over the next 20 years, which is conservative because a relatively small RTO provider sold 11 RTO systems in just the last 2 years. Even with these conservative projections, our revenue projections are over $500 million, resulting in a net present value of $100 million. One of the great things about this technology is it fits so well with program resources. For instance, if invited into this program, we could utilize the Industrial Technology Validation Pilot Program to verify and validate these energy and greenhouse gas reductions of the FBC system. Beyond that, Dr. Andy Sutton in the Chemical Process Scale-Up Group is already excited about catalytically upgrading our terpenes to terpenes and testing the resulting sustainable aviation fuels. In the biosciences area, Dr. Gerald Tuscan's group already has expertise in both terpenes and sustainable aviation fuel. And in the physical sciences district, you have multiple porous carbon experts, including Dr. NASCAR, that could help us develop an optimum carbon reactivation methodology. Beyond this, you have innumerable analytical capabilities. All these capabilities would be very beneficial to this technology. This project fits well within the program timeline. For instance, we're already talking with a bioproducts producer that's interested in doing a pilot scale demonstration, which would take about 6 to 12 months. Then hopefully they'll scale up to the next larger system, which would take about 12 to 18 months. Finally, we could implement 2 to 4 more modules in about a year to provide a fully fielded solution. With Innovation Crossroads, we have the ability and the opportunity to get rid of these gas guzzler RTOs and instead replace them with the energy efficient FBCs. This would provide all of the following benefits, and when scaled at 50 sites, could enable us to reduce energy usage by over 10 trillion BTUs per year, drive down operational costs by up to $150 million per year, enable us to recover 15 million gallons per year of terpenes that could be blended and converted to 75 million gallons of sustainable aviation fuel, and address the climate crisis by reducing greenhouse gases. If a customer must replace the control device anyway, rather than creating more carbon emissions, this technology could enable them to generate revenue, drive down operational costs, and improve the sustainability characteristics of their process as they clean the air. Thank you so much for your time. Thank you.